Okay, let's look at how important mathematics is. But this time we're going to look at setting up an equation. Mathematics is very important, and what you have to understand is setting up the equation is the whole part of solving algebra. It's like building a home. The most important part is the foundation. Once you have the foundation, then you can build the home you want on the foundation. So let's look at it. Okay, knowing mathematics is just like learning how to ride a bicycle. There's a lot to learn, but the more you jump into the driver's seat, the better you will drive. When you first learned how to drive, you surely didn't learn everything about driving the first day. Let's take an example problem and see how important it is to understand mathematics and setting the problem up in the beginning. Okay, here's our problem. A local high school is organizing a debate between Republican and Democratic voting parents. This debate is organized by the student body. The Republican parents desire to sit at rectangular tables with 3 people on each side. The Democratic parents desire to sit at round tables with 8 people sitting around the table. This debate will have 364 Republican and Democratic parents. Over the past 10 years, the ratio of Republican to Democratic parents participating is 2-to-1. Determine how many rectangular and round tables should be rented to facilitate this debate. Let's write out the equation on the problem. Okay, here's our problem. And let's look at the part that's in red. How many rectangular and round tables should be rented? Well, we have this problem here, and we have to take it apart. Okay, so we have to determine from the requirements in this problem what we're supposed to do. So we define the problem. What is it that we are required to do? And specify the requirements for the problem. What is required by the problem? Okay, determine how many rectangular and round tables should be rented. And so to do that, let's let X equal Republican tables, and let's let Y equal Democratic tables. Let's continue. Okay, the Republican parents desire to sit at rectangular tables with 3 people on each side. The Democratic parents desire to sit at round tables with 8 people sitting around the table. Okay, so here we have a table with 3 Republicans sitting on each side. It's rectangular. So we have 3, 6, 9, 12. Well, that means we got 12 Republicans. Okay, to following the requirements of the problem. Okay. Democratic parents. Well, the Democratic parents, there's 8 Democrats. The Democratic parents desire to sit at round tables with 8 people sitting around the table. So we see we have 2, 4, 6, 8 people sitting around the round table. And this is how the Democrats decide to have their debate. Okay, let's continue. This debate will have 364 Republican and Democratic parents. Over the past 10 years, the ratio of Republican to Democratic parents participating is 2-to-1. Okay. Now, what you must remember is that numbers must have units. Okay. So, how many people we had on the Republican tables? Well, we had 12 persons per Republican table. And how many we had on Democratic tables? Well, we have 8 Democrats per Democratic table. These units define the 8 and the 12. Okay? So, we have 12 persons per Republican tables, and we let X equal Republican tables. So we multiply X times 12. If we have 1 table, then we'll have 1 times 12 is 12. So we'll only have 12 people. If we have 2 tables, if we have 2 Republican tables, then 2 times 12 is 24. We have 24 Republicans. Okay? So that's how that works. Plus we have 8 persons per Democratic table. and y is the Democratic tables we're ordering. So 8 times y, and all of these people together is going to be equal to 364. That's from the problem up here. The debate will have 364 Republican and Democratic parents. Okay. Now, the other part says over the past 10 years, the ratio of Republican to Democratic parents participating is 2 to 1. Well, we know X and Y, what they're equal to. X is equal to the number of Republican tables, and Y equals the number of Democratic tables. Okay? And those tables have Republican and Democratic people sitting at them. So, we know that X, the ratio of Republican to Democratic tables is X to Y. Oh, so if we divide both sides of this ratio by X, we get 1 equals Y over X. Okay, let's continue. Okay. Okay, if we divide, here's our equation. 12x plus 8y equals 364. 364 total parents. If we divide our equation by 12x, we get 12x over 12x, which is 1. 8y divided by 12x is 8 over 12 times y over x is equal to 364 divided by 12x. Okay, so we got 1 plus 2y divided by 3x is equal to 91 divided by 3x. Okay, and if we do a little reducing here, we'll get, and reshuffling of our equations, we get 1 plus 2/3 times y over x equals 91 divided by 3x. And you see right here we got y over x. And you remember what we did with y over x in the ratio. We divided our ratio by x. So we have 1 is to y over x, and x is what? 2, and y is 1 from the problem. So if we divide by 2, we get 1 to 1 over 2. So we take this 1 over 2, which is equal to y over x, and we put that into the equation, which is 1/2. So now we have 1 plus 2/3 times 1/2 is equal to 91 divided by 3. And if we do a little shuffling and addition of our problem, our fractions, we get 3/3 plus 1/3 is equal to 91 divided by 3x. If you'll notice up here, 2/3 times 1/2, well, the 2's cancel, so that's where the 1/3 comes from. Okay? Let's continue. So, okay. If we add 3/3 and 1/3, that's 4/3. 3/3 plus 1/3 is 4/3. Okay. So we get 4/3 is equal to 91 divided by 3x. Okay. And if we multiply by 3, the 3's cancel, and we divide by 4, we get 91 4 over 4, or x is equal to 22.75. Okay, so x equals 22.75, and x is equal to Republican table. So that means we need 22.75 Republican tables. Okay. Now, so if we plug in 12 times 22.75 plus 8 times y equals 364, and we solve for y, we get y equals 364 minus 273 divided by 8, and y is equal to 11.375. And what is y? Y is equal to Democratic tables. Okay? So, and according to our ratio, x is to y is 2 to 1. Here is x. X is 22.75. Y is 11.375. If we divide through by 11.375, it gives us 22.75 divided by 11.375 gives 2. So it's 2 to 1, as our ratio stated. Okay, let's continue. So we have x equals 22.75 tables, Republican tables, and y equals 11.375 Democratic tables. Okay? And so since we can't order 0.75 and 0.375 parts of tables, let's round up to the next whole number. So rather than say x equals 22.75, we'll just say x equals 23 tables and y is equal to 12 tables. So we say 12 times 23, x is 23, plus 8 times 12, y is 12, and that's equal to 276 Republican tables plus 96 Democratic tables is equal to 72 parents. So with rounded up numbers, we can accommodate 372 parents. Okay. How does that work? Well, x equals 23 Republican tables for Republicans, y equals 12 round tables for Democrats. So we can seat 372 parents. Let's see why. If we plug into the equation the numbers with fractional parts, we get, to plug in the fractional parts, we get 12 times 22.75 plus 8 times 11.375. That's equal to 364 parents. But since we can't order fractional parts of a table, we must order whole numbers. Okay? So let's plug in the whole numbers. Well, we plug in the whole numbers, and we get 12 times 23 plus 8 times 12 is 372 parents. Okay. So we have 3 extra seats for Republicans and 5 extra seats for Democrats. How did that come about? Well, we got x equals 22.75. Well, 75% of 12 people that sit at that table is equal to 9. Okay. But since we only got 9 people sitting at the table, 9 from 12 is 3. So that means we got 3 extra seats at one of the Republican tables. And since y at the Democrat tables is 0.375, 0.375 of 8 Democrats sitting at the table is 3. And 3 from 8 Democrats is 5. So we got 5 extra seats for Democrats. So 364 parents plus 8 extra parents is 372 parents. Okay. Mathematics is not magic. It's the law. And businesses love math, and so should you. Until next time, thank you. I hope you enjoyed this problem.